couple more things to add. That way we didn't have just a very long set of notes. So I'll put these in here. Still working on binomial probability. Mean, remember, is always your expected value. Our standard deviation is a spread. Now, when we're doing binomials, we can find the mean by, remember, mu of x, n times p, number of trials, times the probability of success. So it's a little bit easier way of getting our mean. And then our standard deviation is going to be the square root n times p, so the mean times the complement. I gotta take the square root of that. So let's look at an example here real quick. Whatever, let's say we're using something, we got 6% chance of success, not the best, and we're going to do 6 trials. So if we wanted to find the mean, we would take 6 times 6%, 0.36. Okay, 0.36. So our mean will be about 36%. Standard deviation, then the spread with all of our data, still using the same thing. 0.94 would be the complement that was calculated, and we get 0.5817, so that means the distance between our data points. So just figure out standard deviation when needed and figure out the mean. So let's look at a couple examples here, some different things. I also want to enlighten you on a calculator, an online calculator that's going to be very beneficial to us as we're doing our problems. So here we go. So using these problems here, let's see if I can get that. There we go. According to the FCC, in this example, 70% of all households have cable TV. I think that's different now, but that's our example. So a couple questions we're going to have out of this. Out of 15 households, so there's your sample, what's the probability that exactly 10 have cable? Now, we can go through and do this. There's our combination. There's a probability of what we want, our success, to the 10th power, because 10 households. And then the probability of the complement, or unsuccessful. Remember, 10 plus 5 are 15. That's just a probability of 10 now. And we can get this long method. Or if you Google binomial random calculator, so if you Google that, and you're going to choose one that says StatTrek, and I would bookmark that site, and plug in this information. All you have to do then is read it. It's already done for you. It's a calculator. And it gives you a couple other options, but right now we said equal to 10, so on our binomial calculator, we have, so StatTrek.com, got our binomial calculator. Actually, I again Google it. Just don't go StatTrek because you have all sorts of different choices. Go binomial random variable calculator. That gets you right there. You don't have to worry about any tabs. So you get your binomial probability calculator. And the first line, probability of success on a single trial, well, we're at 0.7. So we plug in a 0.7. Number of trials that are going to happen, well, 15 households. So we plug in our 15. Number of successes we want exactly 10. So we put that in, and then we calculate. So we hit the blue button on the bottom of it. Now, you get a bunch. You get 1, 2, 3, 4. You get 5 lines of stuff. The first one is when it's exactly equal to 10, and we get this decimal we've rounded. The other ones are less than 10, greater than equal, or less than or equal to 10, greater than 10, or greater than or equal to 10, depending how the questions are worded. That then dictates on which one of those you want to read. So let's look at another one. All right, this one, out of the 15 households, what's the probability that at least, key ingredient here, 13 have cable? So here's what we got going on. Always label my information. N is 15. Probability of what we want, 0.7. What we don't want, 0.3. And we need 13, 14, and 15 households. At least 13. So by hand, boom, boom, boom. Get them all together, add them up. Or, I don't know if you catch the emphasis here, what we're trying to put forth. On the stat track, I got 0.7 as a first line, 15 trials. Number of successes, we want 13 or greater. So I plug in 13, and then I look at my results. After I hit calculate. Now my results for 13 or greater, I look at sorry, I had to pause for a second. So at 13 or greater, I got my list. I see when it's at exactly 13. I see when it's all the way down, but I go down to where the bottom one, probability of capital X is greater than or equal to X, 1268. It's already calculated for you instead of having to do all these lines. Next example. So out of the 15 households, what's the probability fewer than 13? Well, if you look at this problem, 13 or more, fewer than 13. Not 13 or less, fewer than 13. So they're complements of each other. So you can take the answer you got here, subtract it from 1, and get your answer. Or on the stat track, my information is already calculated in there for me. I look at the cumulative probability, and that's where P of capital X is less than X, what we're plugging in at 13, and I can see there's the 0.8732 rounded right there for me. I just got to interpret the information best way that I can. And my final example, now in this one, this won't do it for you because out of the 15, probably the 10 to 12, now we're dealing with 10 to 12 households have cable. So I'm going to use this, but here's how I'm going to go about it. Going back to that online calculator, I'm going to get the probability of 10 of them. So give me a second to plug it in. Although I already have the answer on the paper, I still want to practice doing this. So the probability of 10 out of them was 0.2061. Probability of 11 of them was 0.2186, and the probability of 12, because I'm only going to a certain number here, I'm going to have to do them individually and then add them up. But again, it's been done for you. 0.1700. Add them up, and now you have your answer for 10 to 12. So just a little bit more, a nice little calculator to add to your notes so you can have this to work out the problems.